In his lecture accepting the Turing Award in 1983, Ken Thompson posed a question. If you got a binary like this A.out, how do you trust it? Maybe there's some bug inside the software that's serious enough that you don't want to run it. Maybe it even intentionally does bad things to your machine. One thing you can do is look at all the machine code in this executable and try to figure out whether it does anything bad. But in a better case, you have the source code, so that you can look at the source of the program and look for bad behavior in the source, which usually is much easier to detect than reading machine code. Even if you don't find anything in the source, though, the source is not necessarily the same as the executable, because there is a compiler in between. If there is a bug or bad behavior in the program, then the compiler will copy that into the executable. But what if the problem is in the compiler and not in the original program? Then, no matter how much you look at the source code, you're not going to find the problem. Why would there be a bug in the compiler? Usually there's not, especially these days. If you think you've found a bug in the compiler, probably you haven't. But it is at least possible. So how would you check the compiler? Again, you could try to inspect the compiler's machine code, but maybe you go get that particular version of GCC source code and you read all of that source to look for problems. You can see where this is going, though. The same thing happens there. There might be a bug in the source that you can trace to a bug that's in the executable, or maybe there is a bug that is introduced by the version of GCC that you compile GCC with. Maybe an older version of GCC or a different version of GCC somehow. This, after all, is how GCC normally gets compiled, using some previous version of GCC. It's relatively difficult for a bug in GCC version 12 to turn into a bug in GCC version 13, which turns into a bug in the programs that it compiles. But it's not so hard if the bad thing in GCC version 12 intentionally is bad and intentionally reinstalls itself into any other compiler that it compiles. And then when GCC version 13 is used to compile the program, then GCC version 12, with the bad code inside of it, might have inserted bad code that inserts bad code and the final executable that we get from our program. This bad element in the older compiler could be called a virus, or the compiler itself could be called a Trojan horse, because it's being used to ship in some bad payload into, in this case, compiler, and ultimately into your machine. I would characterize it as a virus because it intentionally replicates itself inside the host of the compiler. So again, how could we make sure that the older version of the C compiler doesn't have a problem? We can keep chasing the sources backwards, but eventually we're going to have to get to the original way that some C compiler got started to start the chain of GCC calls. And if that's just not available, then you can never really be sure that the compiler that you're using to compile your compiler hasn't somehow propagated a virus through it. And this was Ken Thompson's observation. He didn't provide a solution, he just pointed out that this could be a problem that we should start thinking about. In case you're wondering who Ken Thompson was, he was one of the two original authors of the Unix operating system, and he gave his talk in a context where new laws were being written to clarify that virtual spaces are private property the same as physical spaces. And Ken Thompson was worried that young programmers didn't really understand this, and that they were going to get into serious trouble by trespassing on systems where they shouldn't be.